The Colorado flows to the sea. Through rock and sand, canyon and cliff, through the towering formations of the sun-drenched desert, the Colorado flows to the sea. From the towering mountains of Colorado, from the rugged mountains of Wyoming, from the lofty mountains of Utah, from the rolling mountains of New Mexico, come the tributaries of the Colorado, collecting the runoff from more than 100,000 square miles of high plateaus and mountain valleys. The Yampa, the White, and the Roaring Fork, the Minnie-Maud, the Price, and the San Rafael, the Tomichi, the Eagle, and the Uncompahgre, the Sandy, the Chaco, the Cochetope, and the Green, the Gunnison, and the San Juan, down to the Colorado. Stained with the soil of 5 states, the river cuts deep into the desert, into the high walls of Glen Canyon. For 170 miles, Glen Canyon carries the muddy river through the parched red rocks of southeastern Utah, into the sandstone cliffs of northern Arizona. For 40 years, men planned and designed the means to regulate the flow of this river. Every contour of the canyons was mapped and surveyed in the search for the best dam site. In 1956, these men were rewarded for their efforts as the first blast began the construction of the giant Glen Canyon Dam. Bordering on the vast space of the Navajo Reservation, the dam site soon became the objective of a slowly growing army of construction experts. And the machines of heavy construction brought new sounds to this land of the Navajo. New highways were built to reach the dam site, through Arizona and through Utah. New highways through 2 states, each ending at the rim of Glen Canyon. Glen Canyon Dam, a huge construction project, bisected by a 700-foot deep canyon and no way to cross. The only answer was a bridge. A long, high steel span to link the canyon rims. Construction of the bridge was soon underway. The last steel beam, by tradition bearing the American flag, was lowered slowly into position on a hot August morning. And within a few months, the bridge was finished, completing the world's highest steel arch bridge. It was acclaimed the most beautiful bridge in America, open to traffic in 1959. With the opening of new highways and the new bridge, tourists began coming to watch the construction of giant Glen Canyon Dam. The guides point out that the 710-foot high dam is part of a vast undertaking called the Colorado River Storage Project. Many large and small dams will be constructed on the tributaries of the Colorado. But Glen Canyon Dam will be the key structure in this plan for expanded use of water throughout the upper basin states. Glen Canyon Dam's role in the project will be to store great quantities of water to meet downstream commitments. It will not provide irrigation directly, but its priceless reservoir will make possible increased use of far distant upstream tributaries. As a byproduct, valuable electrical energy will be carried over a federal backbone transmission system to meet the need of growing cities and industries. To prepare the canyon, to make it safe for workers below, a group of daring men called high scalers had to comb the canyon walls, removing loose rock. Drilling, trusting to a slender line hanging from the canyon rim far above. Meanwhile, at river level, men with drills, dynamite, and mucking machines began to bite into the sandstone walls. 2 tunnels, each as wide as a house, were cut through a half-mile of rock to divert the river from its channel. In February cold, when the distant mountains slept under a blanket of winter snow, the low flows of the muddy Colorado slipped by the dam site. This was the time to close the cofferdam and to move the river from its bed. Angrily, the water fought to remain, pounding, digging, driving the boulders before it. But eventually, the truckloads of broken rock closed the gap, and the water began moving through the giant diversion tunnels. The Colorado River felt the reins of man's control. Soon the warm spring winds shrank the distant snowbanks, and the new tunnels felt the full fury of the raging river. High above the tunnels on the rock walls of the canyon, men and machines began to cut the keyways, huge notches extending from the rim to the river. The concrete of the dam will be fitted into these keyways to anchor the giant structure into the canyon walls. With the river bypassed and the keyways cut to the canyon floor, power shovels and drag lines began to clear the sand, mud, and gravel from the old riverbed. The men of Glen Canyon prepared for their 4th year of building the dam. Remove the rock, remove the sand, remove the gravel laid down in the ages before man. Get down to the bedrock and wash it clean. 137 feet below the river, the sandstone was laid bare to the sun, ready to receive the massive concrete of Glen Canyon Dam. Midday at the construction site. At the cofferdams, in the foundation area and on the canyon rims, a stillness falls as the men rest and prepare for the task ahead. Midday at the town of Page, 2 miles away. Lunchtime for the wives and families. Page is a city carved from the raw desert when the work of the big dam first began. More than 900 trailers accommodate many of the construction workers and their families. Page was planned for people who want to live in a clean, ordered community, for people who want schools, doctors, stores, and churches, for people who will live here and operate the dam and power plant in years to come. They shop in modern air-conditioned stores, and they have created ways to use their leisure. A land of free-flowing wind, of the blackbrush, the sagebrush, and the dryland grass. A town has grown where none had stood before. A city shaped by the forces of nature, sustained by the efforts of man. At the dam site, the foundation rock that had been laid bare and carefully cleaned was ready for the concrete soon to come. During the years of excavation, giant plants were built to process and supply each of the ingredients that would go into the concrete. Aggregate comprises the bulk of concrete. This rock and sand are washed, screened, and sorted by a large plant 6 miles from the dam site. The aggregate is stored on the rim of Glen Canyon to await delivery by underground conveyor belt to the mixing plant. 188 miles south of the dam site, a new cement plant has been built to convert the limestone and other minerals into 3 million barrels of cement for Glen Canyon Dam. A truck loads and leaves this plant approximately every 40 minutes, day and night. Pozzolan, a natural cement-like material, is used in place of some of the cement to give the concrete more desirable qualities. Pozzolan is obtained from a volcanic deposit near Flagstaff. There it is finely ground and trucked to the dam site. Even the water to be mixed with the concrete requires a plant. A mammoth refrigeration plant, the largest yet used in building a dam. Here, ice is produced in vast quantities to be used in place of some of the water in the mixed concrete. The refrigeration plant also cools water to be pumped through tubing embedded in the dam itself. The cold water carries away chemical heat generated as the concrete cures. And the most important plant of all, the mixing plant. Perched like a fortress on a ledge of the canyon, this towering plant is as high as a 20-story building. Ingredients are fed into this plant where they are measured, mixed, chilled, and tested to produce heavy, wet concrete. The final step is the swift lowering of the concrete from the mixing plant into the canyon. Great cables attached to moving towers on each rim swing the buckets to any spot on the dam or power plant. On June 17th, 1960, everything lay in readiness for the first bucket of concrete. A large crowd assembled on the high bridge to watch the operations far below. Almost 4 years had been spent in the canyon, excavating, building plants, getting ready. But all preparations were now at an end, as the elaborate machinery that would feed concrete to the great dam was set in motion. The Secretary of Interior had pulled the lanyard, releasing the first 12 cubic yards of concrete onto the rock floor. The first bucket, first of over 400,000 to be mixed in the noisy clatter of the concrete plant and sent sailing to the white barrier below.
That's RED. Still RED. Right. Hey, wants another half a bucket down the river, Bob. Going highball. Hold your travel.
The dam is built in blocks that will be later sealed together with cement grout to make the dam a single solid concrete mass. The biggest individual blocks are 70 feet wide and 220 feet long. From the canyon rim, the scene appears to have little activity. An army of workmen virtually hidden in the Great Canyon. Swiftly, the great buckets drop their loads of concrete. And slowly, the massive dam rises skyward. As actors in the drama of the Colorado, the workmen in the canyon below now hold the stage. But soon other men will have their turn. Men who now wait and prepare. In a plant near Flagstaff, men fabricate the penstocks, giant steel pipes that will carry the cold, clear water through the dam to drive the turbines and generators. Some of the penstock sections weigh as much as 100 tons. Trucks carrying these to the dam site can travel only 15 miles an hour. Cities and industries in the Intermountain West wait for electrical energy that will come from Glen Canyon Dam. Farmers and ranchers in Colorado, Wyoming, Utah, and New Mexico wait for irrigation projects made possible because Glen Canyon Dam and other storage units will control the upper Colorado River. And in scenic Glen Canyon, National Park Service rangers prepare for the influx of visitors who will boat, fish, and swim in the blue waters behind the dam. The Glen Canyon Reservoir has been named Lake Powell in honor of John Wesley Powell, explorer, scientist, and early proponent of reclamation in the West. As the waters rise in Lake Powell, the narrow side canyons will become intriguing inlets of matchless beauty. Higher on the red cliffs, the water will lap against rock formations now rarely reached by man. A new hour has come for Glen Canyon, for the Colorado River, and for the people who look to the river for the benefits it can bring. The harsh sounds of drag lines and power shovels have echoed through the desert canyon, but they are heard no more. Now the roar of concrete mixers, sandblasters, and pumps fill the air. But these too will shortly be gone. Soon the hum of generators will replace the sounds of construction in the deep gorge. And Glen Canyon Dam will endure, an important and noble venture for tomorrow.